The setup features various white flowers, such as daisies and carnations. These flowers are selected for their pure white petals. Celery stalks are also included in the display. The celery stalks are highlighted for their white stems. The arrangement emphasizes the natural whiteness of the plant materials. The display is set up indoors, under natural daylight conditions. The scene is set in a laboratory, focusing on the preparation of glassware. Clear glasses or vases are carefully arranged on a table. Emphasis is placed on the cleanliness of the glassware to ensure accurate experimental results. The transparency of the glass is highlighted, indicating its suitability for observation. Proper arrangement ensures accessibility and organization during the experiment. The setup is meticulously prepared to maintain a controlled environment. The scene features a lab setup, indicating a controlled environment for observation. Multiple bottles are displayed, each containing a different food coloring. The food colorings include a range of primary and secondary colors. The vibrant colors are prominently showcased, highlighting their intensity. The display serves to visually represent the variety of available color options. The setup suggests a demonstration or experiment involving color mixing or analysis. The initial step involves preparing the necessary tools for flower stem trimming. A pair of scissors is essential for making clean and precise cuts. The scissors should be sharp to avoid crushing the stem. Clean cuts promote better water absorption for the flowers. Trimming the stems is a crucial step in flower care. Proper trimming enhances the longevity and freshness of cut flowers. Glasses are being filled with water. The focus is on showcasing the water's clarity. The indoor setting provides controlled lighting. The filling process highlights the purity of the water. Different food colors are introduced into separate glasses of water. Each glass of water visibly changes color upon the addition of the food coloring. This demonstrates the basic principle of color mixing. The resulting colors vary depending on the type of food coloring used. The process begins with the introduction of food coloring into water. A stirring rod is used to agitate the mixture. This agitation promotes the dispersion of the coloring. The goal is to achieve a uniform distribution of color throughout the liquid. Even distribution ensures consistent color saturation in the final solution. Flower stems are trimmed to prepare them for optimal water absorption. The trimming process involves cutting the stem at an angle. Scissors or a sharp knife are commonly used for this purpose. An angled cut increases the surface area available for water uptake. This ensures the flower receives adequate hydration, prolonging its freshness. Proper stem trimming is essential for maintaining the flower's health and appearance. Each flower is trimmed to the desired length. A glass is prepared with colored water. The color is achieved by adding dye to the water. One trimmed flower is gently placed into each glass. This process is repeated for each flower. The base of the flower stems are placed in colored water. This allows for direct observation of water absorption. The close-up shot enhances the visibility of the process. The colored water serves as a visual tracer. This allows the viewer to see how the water travels up the stem. The camera is positioned to record a sequence of images over an extended period. This technique, known as time-lapse photography, captures changes that occur slowly. In this setup, the focus is on documenting the blooming process of flowers. The camera will automatically take photos at set intervals, such as every few minutes. These images will then be compiled into a video, compressing hours into seconds. The resulting time-lapse will visually showcase the flower's growth and transformation. Capillary action allows water to move upwards through narrow spaces within the flower stem. This process is driven by the adhesive forces between the water and the stem's inner walls. As the colored water ascends, it visually demonstrates the principle of capillary action. The time-lapse captures the gradual movement of the water, highlighting the continuous nature of this phenomenon. The experiment demonstrates the ability of flower petals to absorb colored water. White petals are used to clearly visualize the color change. The petals gradually change color over time. The color of the petals mirrors the color of the water in which they are placed. The scene focuses on a close-up observation of flower petals indoors. Intricate patterns of color are visible on the petal surfaces. These color patterns are a key feature of floral aesthetics. The observation takes place during daylight hours. The close-up perspective allows for detailed examination of the petal's surface. The flowers exhibit a dramatic change in coloration. The colors are now vivid and intense. This transformation highlights the flower's development. The vibrant hues showcase the final result. The flower's appearance is now visually striking. The scene presents a side-by-side comparison of flowers. Original white flowers are displayed next to colored flowers. This juxtaposition highlights the visual transformation. The comparison emphasizes the color change achieved. The visual contrast underscores the impact of the coloring process. Flower stems contain specialized internal structures essential for plant function. One key component is the xylem, a network of tiny tubes within the stem. Xylem's primary role is to transport water and minerals from the roots to the rest of the plant. This upward movement of water and nutrients is crucial for photosynthesis and overall plant health. The structure of the xylem is optimized for efficient and continuous fluid transport. Understanding xylem's function is key to understanding plant physiology. Capillary action is a crucial mechanism for water transport in plants. It specifically facilitates the upward movement of water within the xylem tubes. Xylem tubes are narrow, specialized vessels that form a continuous network from the roots to the leaves. Capillary action occurs due to the cohesive forces between water molecules. Adhesive forces between water molecules and the xylem walls also contribute. This combined effect allows water to defy gravity and ascend through the plant. Capillary action is driven by the forces of adhesion and cohesion acting on a liquid. Adhesion refers to the attraction between water molecules and the walls of a tube. This adhesive force causes water to climb the tube walls. Cohesion, on the other hand, is the attraction between water molecules themselves. Cohesion allows water molecules to stick together, pulling other water molecules up as the first layer adheres to the tube. Water is essential for plant life, serving as a crucial transport medium. The animation illustrates the process of water movement from the roots up through the stem. This water carries dissolved nutrients and minerals, often visualized as colored water in animations. The stem acts as a conduit, facilitating the upward movement of water and nutrients. Ultimately, the water and nutrients reach the petals, supporting their growth and vibrant color. The animation demonstrates the process of petal coloring. Colored water is absorbed by the petals. The colored water spreads throughout the petal structure. This process results in a change in the petal's color. The animation visually represents this color transformation. Capillary action is essential for plants to draw water and nutrients from the soil. Water molecules adhere to the walls of the plant's xylem, a process called adhesion. Water molecules also cohere to each other through hydrogen bonds, known as cohesion. Adhesion and cohesion work together to pull water upwards against gravity. This capillary action enables water and dissolved nutrients to reach the leaves for photosynthesis. Capillary action is the ability of a liquid to flow in narrow spaces, without the assistance of, or even in opposition to, external forces like gravity. This experiment demonstrates capillary action using celery stalks placed in colored water. The colored water is drawn up through the celery stalks, visualizing the movement of liquids in narrow spaces. This process is similar to how plants draw water and nutrients from the soil up to their leaves. Celery stalks demonstrate capillary action, drawing liquids upwards. Colored water is absorbed through the base of the celery. The water travels up the xylem, the plant's vascular system. This process results in the coloration of the celery leaves. This experiment demonstrates capillary action, a key process in plants. Capillary action is the force that enables water to move upwards against gravity. This force also facilitates the transport of nutrients from the roots to the rest of the plant. The colored flowers visually confirm that water travels upwards through the plant stem.